Hi, non-resident training course, September 1998, Navy Electricity Electronic Training Series, Module 9, Introduction to Wave Generation and Shaping, Navy Trial 14181. Chapter 2, Summary. Alright, this chapter is presenting information oscillators, information file summary of the important points of the chapter. The wave generators can be classified according to syncytial, non-syncytial waveforms. Syncytial wave generation oscillators produce a sine wave with a constant amplitude with a frequency. There are three ways to control frequency and sine wave generation: resistor capacitor networks, inductor capacitor networks, and crystals. Non-syncytial wave generators oscillators generally complex waveforms such as the square waves, rectangular waves, sawtooth waves, trapezoidal waves, and triggers. Non-syncytial wave generators are often called relaxation oscillators. A basic oscillator can be thought of as an amplifier that provides itself with a single input feedback amplifier output. Oscillator is divided and converted to DC power to AC power. It is predetermined frequency requirements for the oscillator amplification, regenerative feedback, and a frequency determining network. Feedback amplifier frequency determining network capacitor inductor capacitor. Oscillator has two stable requirements of amplitude stability and frequency stability. Feedback: the process of the transferring energy with a high level of the point of the system, and low level of the point of the feedback of the aids input with the regenerative power of the feedback of the opposed with the input signal that degenerated negative. The three basic circuit configurations for the oscillator: common collector, common base, and common emitter. In the common collector configuration, there is no phase shift with the input and output, but it's not necessary feedback network to provide the phase shift. The voltage gain is less than unity, and one power gain is low with a very seldom used as an oscillator. In common base, the configuration is a no phase shift between input and output, and is not necessary for the feedback network to provide a phase shift. The voltage power gain with high enough to give the satisfactory operation oscillator emitter. The oscillator circuit. Alright, in the common emitter configuration is 180 degrees phase shift between the input and output. The feedback and network must provide with another phase shift of 180 degrees that has a high power gain. Alright, common collector configuration 0 degrees. Also no phase shift in the common base, and then a phase shift of 180 degrees in the common emitter. Armstrong oscillator. Used to provide the sine wave output with a constant amplitude with a fairly constant frequency. An oscillator in which the DC power is supplied with a transistor for the tank circuit or a portion of the tank circuit is a series fed. An oscillator where the DC power supplied is a transistor with a path separate and parallel to the tank circuit is parallel and shunt field. A Hartley oscillator is used to provide a sine wave output with a constant amplitude with fairly constant frequency. Colpitts oscillator is used to produce the sine wave output with a constant amplitude, very constant frequency with a radio frequency range. Identifying feature for the Colpitts oscillators are the split capacitors. Resistive capacitor feedback oscillator is used to produce a sine wave output relatively constant amplitude frequency with a resistor capacitor network to produce feedback and eliminate the need of the inductor of the resonant circuit. Alright, your crystal oscillator are the oscillators that use a specially cut crystal with the control of the frequency. The crystal can activate each of the capacitor inductor series tune circuit or parallel tune circuit. Pulse oscillator, syncytial oscillator that is turned on and off for the specified time duration. Frequency pulse oscillator is determined both in input gating pulse and the resonant frequency of the tank circuit. Harmonic is a syncytial wave that having a frequency that is multiplied, that is a multiple of the fundamental of the frequency. The frequency of the multiplied harmonic generators are specialist class C amplifiers. They are based on 3 to 10 times normal cutoff. They usually generate the frequency that is multiple of the harmonic of the lower frequency. Buffer amplifier decrease the loading effect for the oscillator, reducing the interaction between the load and the oscillator. And that was Chapter 2's summary.